This is Mr. Z recording from my basement while Amelia naps. So, on collegeboard.org, they have, under the SAT, a whole bunch of stuff on here. And specifically, if you go to this little drop down and you click on practice, they have official practice tests, which you can click here to get. And what I'd like to do is make some videos where I go through how to do some of this stuff. So the first one I'm going to look at actually is SAT practice number 10. So to get the actual test ahead of time and try these on your own, you would click this button, and there's the whole test. In this video, we're going to do the math no calculator. So wherever that is, I think it's test number 3. Starting here on page 38. There's about 20 questions. Try them on your own, see what you can do, and then check back with this video.
I switched over my tablet now. A couple things to emphasize. This is a no calculator test, but you could use any one of these formulas if they are helpful. Most of the time they're not. So number 1, it probably is trying to get you to make some mistakes. We usually subtract the smaller of the two z values, so it's tempting to do this. If you do that, though, then you end up z plus 1 equals, and this is where students tend to go wrong, because they're not sure what to put there, and you should put a 0. So then you could subtract 1 and get that z is equal to negative 1, and that's your answer. The predicted mistake being we don't put a 0 here, and we're not sure what to do. Of course, you could have just subtracted the 2z and went from there, and then maybe you forgot to divide by a negative. Easy question, lots of potential mistakes. Number 2. A television is purchased with a price of $300, and we have initial payment and then weekly payments. So that's important because this is probably going to be linear, and anytime something is a one-time or initial cost, that means it's our y-intercept, and the weekly or recurring payments are going to be our slope. So this is just going to be that the price of $300 is equal to 30 times some number of weeks plus 60. Oh, they used WIC. But other than that, C is our answer. Remember that initial or one-time payments go over here as our B value, and weekly or recurring payments go as our slope, right here. But what a dream world that we have no taxes or fees, my goodness. Number 3, the table above shows shipping charges for an online retailer that sells sporting goods. And we see that there's this relationship between pounds and shipping charge that they describe as linear, which means it's a consistent rate of change. So we can build y equals mx plus b a function. Which function can be used to determine the total shipping charge in dollars for an order with a merchandise weight of x pounds? So like most linear problems, there's a variety of ways to do this. Personally, I would probably just treat 2 of these as if they were coordinates. And then I'd use the change in, or the slope formula. So I'm going to plug in the difference in my y values on top and the difference in my x values on bottom. Now, perhaps without a calculator, that kind of subtraction throws you off a little bit, but it's about $10. And since we're dividing by 10, that means we're going to be scooting our decimal place over. So it looks like this. And it becomes 0.99. So we know that it's either going to be A or B, one of these two. That slope is. So I could use the formal formula to find B, but what if I just thought about my first value here, 5 and 16.94. So 5 pounds times 99 cents, we'll call that $1, is about $5. Is that the shipping charge? No, we have to add something like $11 or $12 to that. So A is wrong and B is correct. Number 4, the line in the xy plane above represents the relationship between the height in feet and the base diameter in feet for cylindrical Doric columns in ancient Greek architecture. So the height and the base diameter. How much greater is the height of a Doric column that has a base diameter of 5 feet than the height of a Doric column that has a base diameter of 2 feet? So 5 versus 2. So we're going to be plugging in the base diameters on the x-axis because it tells us it's x. And h of x is where we get y. That's our y value, or our output. So if we start here at 2, and then we're comparing that to 5, or they're saying how much greater is the height for 5 versus 2, we just measure the difference. We see that this one is 35 and this one is 14, so we subtract 35 minus 14, and that's where we get 21. Number 5, not too bad if you know your exponent rules. You could, if you wanted to, think of this as square root of 9 times the square root of x squared. You don't really need to, but you could, and this gives you 3x, and that is just actually your final answer. If x was negative, which it's not, or 0, then things would change, because 0 would just make your final answer 0, and something negative, now we're getting imaginary numbers. But we can take the square root of both separately. A is our. With number 6, we're going to use, back from quadratics and algebra, the difference of squares formula. And that says that when we have an x squared minus 1 without our b term, like 3x or something, it's going to become this, x plus 1 times x minus 1. If we were to factor that out, or multiply that out, rather, we would find it is equal to x squared minus 1. This is very helpful because then we can cancel this out. Top divided by bottom just goes away. The resulting problem is quite a bit easier. We just subtract 1 from both sides and we get negative 3. Number 7 requires you to understand function notation. F of 0 just means when x equals 0, what is y? And if you got that, this is a pretty easy problem, because here's x for 0, and we follow it up, and the answer is 4. So we're told that AD is a segment, meaning it has 180 degrees, and since this over here is 90, x plus 2x plus 2x is equal to the remaining 90. If 5x is 90, divide 90 by 5, what do you get? 18. Oh, just kidding. See how easy it is to make a mistake? They actually asked, what is the value of 3x? So I have to take 18 times 3, which gives me 54. That's a common trick at the end. What is the value of 3x instead of x? So if you're going fast or not paying attention, very easy to make that mistake. So for number 9, we're trying to find the equation of a line. And the first thing that I noticed is b, you can just tell right off the bat. That's where the line crosses the y-axis, here at negative 4. And to find the slope, normally we would take 2 points, but it's kind of just following this very easy to identify pattern of down 1 over 1. My slope is just going to be negative 1. So if I wrote my equation, I would get y is equal to negative x, or negative 1x, minus 4. I don't see that anywhere, but what happens if I add x to both sides? Y plus x is equal to negative 4. C. So number 10 is a quadratic problem, and this one is actually not that hard if you understand what they're asking. This intercept at 0k can be found by taking a 0 and plugging it in wherever you see x. So y is equal to 2 times 0 squared, which is just 0, plus 10 times 0, which is just 0, and the only thing left is 12, which is your answer. Number 11 requires you to understand the circle formula. And this is what that formula looks like. X minus h squared plus y minus k squared is equal to r squared. That's for a circle with a center of h comma k and a radius of r. So they give us all three of those values, the x and the y coordinates of the center, that's h and k, respectively, and they give us the radius too. So x minus 5, which could be this one or this one, y minus 7, still good, and radius squared. Not this one, but this one. A is your answer. Number 12, similar triangles. Since they are similar, that means that the angles are the same and that the side lengths are proportional. So if they want to know what the cosine or the value of cosine E is, I can use the adjacent and the hypotenuse from the smaller triangle, because these angles are going to be congruent. So this goes back to SOHCAHTOA, and since I'm using cosine, I want the adjacent over the hypotenuse. So I could write this as the cosine of, it could be B or E, I'll put B for now, is equal to 12 is the adjacent side, divided by my hypotenuse, 13. And that turns out to be the exact same thing for E. So I can just circle that, choice B. Because the triangles are similar, the angles are congruent. In the xy plane, the graph of the function f of x is equal to x squared plus 5x plus 4 has two x-intercepts. What is the distance between the x-intercepts? I like to use the x method to factor a quadratic like this. So what I do is I think about ax squared plus bx plus c. And on the top of my x, I put the factors of a times c. So here my a value is 1. So that's just going to be the factors of 4. These are things like 2 times 2 or 4 times 1. And the question is, which one of these is going to add up to 5? 2 plus 2 or 4 plus 1? Because my b value is 5 here, so it's going to be 4 and 1. If you multiply them, you get this top value. If you add them, you get the bottom. You might have learned a different method to factor, but it should look like this when you're done. And these are the two x-intercepts, or at least it'll give you the two x-intercepts, because what value can you plug in for x to make this 0? It's just the inverse, -4 and -1. What's the distance between these three? The distance between these is 3. 13 is C. So looking at number 14, it's tempting to try to square both sides and turn it into a quadratic and maybe factor it and see what my zeros are. But I think it'd probably be easier if I just plugged in numbers. Let's test the first case. The square root of 4 times 1, or the square root of 4, is 2. Is 1 minus 3 2? No, it's actually -2. So the first case doesn't work. What about the second one? Well, the square root of 4 times 9 is the square root of 36, which is 6. And on the right, it's 6. So that one checks out. The answer is B, number 2 only. Just plug it in, go from there. For number 15, the best hint for solving the systems is that the system has no solutions, or for what value of a does it have no solution. The only time a system of equations has no solution is when we have two parallel lines, because they never cross. Otherwise, these two lines, wherever they cross, is the answer. That's the solution. For that to be true, the slopes have to be the same. So I might take this top equation and move the 3x over, and that tells me my slope has to be 3. And the second equation, I can do the same thing. I move the ax over to the other side and divide everything by 2, because I have to get y by itself. So what I'm looking at is, when does this equal that? So I might first multiply by 2, and this gives me 6 is equal to -a. If I divide out the negative, I have -6 is equal to a. A is my answer. Number 16, we have to interpret from this paragraph where to plug in various numbers. They tell us that the total shipping cost is T, so total shipping cost 47,000. That's a pretty easy substitution. But then this C and F get tricky because they're both shipping units. Shipping C units to the closer, C for closer, and F units to the farther. So C is equal to closer, F is equal to farther. And when they say 3,000 units were shipped, it's very tempting to just plug that in and say, oh, shipping C units, plug it in for C, but it's actually plugging in for F. So we leave 5C all by itself, and 3,000 goes over here. So we can take 12 times 3 to get 36,000, and we subtract next. We end up with 5C is equal to 11,000, and remember, no calculator, so how can we do this? Well, you could probably struggle your way through this if you thought about it. But we could just double both sides. Then we get 22,000 is equal to 10C. And how do we divide by 10? We knock off a 0. So there's our answer. 2,200. Number 17, absolute value problem. So that means we split, and we have two possible answers. Here on the left, we have that 2x plus 1 is equal to positive 5, and here on the right, we have the negative solution, 2x plus 1 is equal to -5. We're going to subtract 1 from both sides on both equations. Then we're going to divide by 2 on both sides for both equations. So our two solutions are 2 and -3. So whether I take 2 minus a -3, which is 5, or -3 minus 2, which is -5, when I take the absolute value of these, the answer is just going to be 5. 18, we're looking at exponential growth. We see that here with the increased 10%. So we could take 10% and say that we're looking at 220 the next year. And after that, we're looking at 242. But they don't want to know the actual value 2 years after purchase. They want to know, using the expression 200a, where a is a constant, what is the value of a? So we think about 10% growth, and that we take 100 plus 10 is equal to 110. And to put this as a decimal, we move the decimal place over twice, and we're looking at 1.1. So we start off with 200, and after the first year, we multiply by 1.1 to add 10%. And then for the second year, we multiply by 1.1 again. So what this problem is asking is, what is the product of these two? 1.1 times 1.1, which might seem tricky without a calculator. But let's imagine that these were 11s. And to do so, I'll just move the decimal place over for each of them. And we have 11 times 11. Hopefully you know that's 121. If you don't, that's okay. And I moved the decimal place over once for each of them, so I'm going to move it back over twice. Turns out 1.21 is my final answer. 19. Based on the system of equations above, what is the value of 5x plus 5y? So you could solve this for x, and then solve for y, and then plug these in and add it all together, but thinking about the rules of elimination, what would happen if I just added straight down all three columns? On the left here, 2x plus 3x is 5x. In the middle, 3y plus 2y is 5y. And on the right, 1200 plus 1300 is 2500. And what is the value of 5x plus 5y? 2500. You're done. If you saw that, life was easy. Otherwise, you probably did quite a bit of work. Still would get the same answer, I suppose, but... Last one, and I might actually finish this before she wakes up. So I can substitute for u minus t here what it's equal to, which is just 2, and I'm left with 2 times u squared minus t squared. And this again requires the difference in squares formula. So this can be changed to u plus t times u minus t. If I was to expand that, I would get the original. And here is where I can replace u plus t with 5. So 2 times 5 times u minus t. Or excuse me, this last one can also be replaced with a 2. So 2 times 5 times 2 is 20. The final answer.